This is worksheet 8-5, problems 11 and 12. The directions state use a calculator to solve each problem. Number 11 reads, how much would an initial investment of $500,000 be worth after 10 years if invested at an annual rate of 3.75% compounded continuously? There's the magic word. So that tells us we're going to use our new formula. A equals P times E raised to the power of R times T. All right, so let's take our question and identify the information. We know that this is going to be our principal, the $500,000. We know that the 10 years is going to be our time, and our rate is 3.75%. Let's plug them in and find the value. So A is going to equal 500,000 times E raised to the power of 0.0375, right? That's how we write 3.75% as a decimal. And we're going to multiply that times 10 for the time. And now we'll just pull out our calculator and type it in. So 500,000 times E raised to the power of 0.0375 times 10. Hit enter, and you will find that the value is now going to be $727,495.71. Now let's go on to number 12. How long will it take an investment to triple if compounded continuously at an interest rate of 7.79%? So this one, it kind of seems like we're missing some information, right? So if we think about this, I'm going to just recopy my formula. A equals P times E raised to the power of RT. What they're saying here is we're going to take our investment, our principal, and we want it to end up tripling after some amount of time. So when you think about the relationship between our principal and our final amount, right, we want that final amount to end up being 3 times what our principal was at the beginning. So we want A to equal 3P. So let's just actually plug in 3P in the place of A. So I have 3 times the principal should equal the principal times E raised to the power of RT. And if you don't like that, you could always take a number and plug it in. You could say let P equal 100, and then you would have 300 equals 100 times E to the power of R times T. Because here's what's going to happen now, right? I have a couple variables and things in here, but I'm going to go ahead and plug in the other parts that I know, right? So I have that 7.79%, right? So I'm really saying 3P is going to equal P times E raised to the power of 0.0779 times our T. And T is what we're looking for, right? Because it says how long will it take? So as I look to try to solve this, what I'm going to do first is I'm going to divide each side by P. Right, we cancel those P's out, and actually these P's will cancel out. Now we're left with 3 should equal E raised to that power of 0.0779 T. And now it's just an exponential function that we need to solve. So what I'd say here, because this is new, right, if I want to get rid of that E, right, let's take the log on each side. But when we take the log, let's do the natural log. Whoops, I don't know why I drew an H, but let's do the natural log. So if I do the natural log of E to the power of 0.0779 T, and that equals the natural log of 3, now I can take this and simplify this down. Remember, my exponent is going to end up moving out in front. So I have 0.0779t times the natural log of e, which we know is actually just 1. And that equals our natural log of 3. So this 1 becomes irrelevant, and we can actually just take this and say, hey, the natural log of 3 equals 0.0779t. And if I want t by itself, I'm just going to divide each side. So this would be the part where the calculator will probably help us. We'll say the natural log of 3 divided by 0.0779. And we get that t is going to equal about 14.103 years. And that is our answer. So here's our answer for 11 again. If you have questions on either of these, please make sure you reach out. Otherwise, thanks for watching.